Hi everyone. So today we are going to be talking about the remainder theorem. So remainder theorem, I would like us all to be on page 10. So let's make sure we're on the correct page. So the remainder theorem is actually pretty cool. It's actually going to show us that when we plug in certain numbers, it's going to tell us what the remainder is for our polynomial. So you guys have seen with long division and synthetic division what the remainder is. Okay, so using long division and synthetic, you've seen how to find a remainder. But we're actually going to be using a different theorem now to get the remainder even quicker. Okay, these methods are pretty more strenuous. So let's take a look at the first exercise. So we're given the following polynomial, and we want to evaluate f of 3 and f of negative 2. All right, so I'll just do the first one for you, and then you guys can do f of negative 2. So let's just plug in. This is when x is 3. Right, and you guys know this is when x is negative 2. Now, you should not be using a calculator for this. Okay, we do not need calculators. So we have f of 3 is equal to 2 times 3 cubed minus 3 squared plus 2 times 3 minus 3. This is just purely mental math. All right, so I'm just writing out all of these evaluated pieces. And what do we end up getting? 2 times 27 minus 9 plus 6 minus 3. That ends up being 48. So why don't you guys do part B? You shouldn't really need my help for this, so try part B. All right, so I wrote this out for us. I ran out a little room here, so this minus 3 is really at the end here. We're just subtracting it out. And we end up getting negative 27. So there is, and obviously there's a point of doing this. It's applying to the remainder theorem. So let's see, let's actually use synthetic division on each of these. So let's see, let's use synthetic division on x plus 2 of the same polynomial, and let's see what happens. So let's use synthetic division on this. So we have the root would be negative 2. So we have negative 2. We would have 2, negative 1. 2 and negative 3. Bring down the 2, right? We're just running through synthetic division. Negative 2 times 2 is negative 4. We have negative 5. This would be positive 10, 12, negative 24. And we're left with negative 27 as my remainder. Okay. Well, all right. No worries. Let's see what happens now in part B. Using synthetic division, okay, we want to see if now x equaling 3, if that's a root for the given polynomial. Notice it's the exact same polynomial as over here, and there's a reason for this. You guys are going to see. Okay, so let's just run synthetic division and see what happens. So we have 3, we have 2, negative 1, 2, negative 3. Again, bring down the 2. We have 3 times 2 is 6, and we have negative 1 plus 6 is 5. 3 times 5 is 15. 15 plus 2 is 17. 17 times 3 is 51. Combine like terms here and we get 48. Now, hopefully, maybe you notice. Let's zoom out here and look at the whole page. What do you guys notice about part A here with part B down here? And then part A here with part B here. They're the same. The remainder is the same. So using synthetic division, I think, is a longer way. The way that we can actually find the remainder of a given polynomial is literally plugging in the x value. That's what we did here. Plug in when x is 3, boom, there's my remainder. Plug in when x is negative 2, boom, there's my remainder. This is a little bit longer of a way, I think, using synthetic division, because you got to go through all the multiplication, whereas remainder theorem just says plug it in. What do you guys think is if the remainder is 0? What do you think is if you have a remainder of 0? What do you think that means? So pretend, we went through the synthetic division. We have all these numbers here. Okay, all these numbers, whatever they are, doesn't matter. And in the end, we're left with 0 here. And let's just make up, I don't know, maybe this is 2x squared plus 2x. Sure. I'm just writing it out. If there's no remainder here, then whatever this number is means that it's a factor. So remainder of 0 means It is a root or a factor of the polynomial. All right, so let's just get into some more practice problems. Okay, so just on the next page, page 11, I ask you to perform long division on the given polynomial and what's the remainder. So we could do this with long division, or we can use the remainder theorem. All right, but let's do this with long division first. Again, I want you guys to see how much longer of a process this is, whereas remainder theorem is going to be a lot quicker to use. So if we do long division here, we have x times x gets me to x squared. Multiply back. I'm just going through this a little quickly because we've already learned how to do this. We'll end up with 4x, right, because this is plus minus the 10. X times 4 gets us to 4x, so let's multiply it back. And I'll have 4x minus 4. Keep change. And we have negative 6 as my remainder. Okay, so the remainder is negative 6 using long division. Now that's a longer process. What if we just plugged in x to equal 1, right? What if we just plugged in x to equal 1? Well, let's see. I have 1 squared plus 3 times 1 minus 10. That's 1 plus 3 minus 10, which is negative 6. You see how much easier and quicker this setup was? Remainder theorem is going to be your friend, guys. All right. Why don't you give question exercise 3 a try? Exercise 3. All right, we're given the function. We want to find g of negative 5. All right, so pause the video here and do that one yourselves. All right, so hopefully you got the same answer as me when you plug in x to equal negative 5. You find that the remainder is 0. So x equaling negative 5 is, in fact, a root. Okay, let's keep going. Okay, so let's take a look at question 3 here. So this is now on page 12. So it says, find the remainder given the following polynomial divided by x plus 2. So now, again, you can do this with synthetic division, or we can just do it with the remainder theorem. So let's just do it with the remainder theorem. We have x equals negative 2, and we're just going to plug it in. We're just plugging this in. And after all of this simplification, what we have, negative 8 plus 2 times 4 minus 6. Negative 8 plus 8 is 0. My remainder is negative 6. So that was pretty quick and easy. Again, we could have done this with synthetic division, but I think that's a lot longer. So let's just do it with synthetic division again, just so you have that confirmation as well. We have negative 2, 1, 2, 3. There's a 0 here because of that constant. Remember, you got to make sure you include all of the terms. So we would just bring down the 1. This would be negative 2. 0 times negative 2 is 0. We have 3. Negative 2 times 3 is negative 6. And there's your remainder of negative 6. Again, I think this is longer. You also could have made the mistake of forgetting the 0. Maybe you would have found the remainder to be 3 if you did it with synthetic division because you forgot that placeholder term for the constant. Okay. All right, let's move on. Let's go over to question 5. Question 5. I love these kinds of questions. So we have if t to the 4th minus 2t squared minus t plus k is divided by the following, and the remainder is 15, what's the value of k? So we have this t to the 4th minus 2t squared minus t plus k is being divided by t plus 2, and its remainder is 15. Okay, its remainder, I shouldn't write it like this, sorry. Its remainder is 15. So what are we going to do? Well, we probably want to use the remainder theorem. So if we're dividing something by t plus 2, what does t then equal? What's the root? If we're dividing by t plus 2, what does it equal? Right? We always said our factors equal to 0. So my root is really t equaling negative 2. Okay, so let's plug in. We have negative 2 to the 4th. So I'm plugging in here, plugging in negative 2 here. Negative 2 to the 4th minus 2 times negative 2 squared minus negative 2 plus k equals, this is equal to the remainder, right? When we do this, we end up finding what the remainder is. And our remainder in this case is 15. So set it equal to 15. Now you cannot put this whole thing in the calculator at once, which you shouldn't be using a calculator in general. We should be doing this by hand. Negative 2 to the fourth, that's 16, minus 2 times 4, plus 2 plus k. Again, I'm just simplifying. So we have 16 minus 8 is 8, plus 2 plus k. All this is equal to 15. And we end up getting 10 plus k is equal to 15, right? 8 plus 2 is 10. So I'll write this over here. 10 plus k is equal to 15. So k is equal to 5. I love these kinds of questions. All right, so k is equal to 5. All right, let's take a look over to the factor theorem. Factor theorem, what a great theorem to use. Again, it's going to help if we use this instead of synthetic division or log division. This is going to save you time. So factor theorem, well, let's see. We're going to find what the remainder is of these polynomials if they're divided by these given factors. So if we're dividing by these given factors, remember, that just means that's what we're plugging in for x. We would have x equal 5 here, and x equal negative 3, if it's a root. If it's a root, that's what x is equal to. If it's not a root, we'll get a remainder, right? So let's see. We're just plugging in. F of 5 is equal to, I have 5 cubed plus 6 times 5 squared plus 2 times 5 minus 21. And I end up getting f of 5 to equal 264. So that means this is not a factor. Okay? Not a factor of the polynomial because I got a remainder. That's my remainder. If I get a remainder of 0, then yeah, that's the factor. So let's take a look at x plus 3. We're plugging in now x to be negative 3. So I have f of negative 3 equals negative 3 cubed plus 6 times negative 3 squared plus 2 times negative 3 minus 21. And again, just to save us some time, this ends up being 0. That's my remainder. If my remainder is 0, then yeah, this is a root, and x plus 3 is the factor. So the factor theorem says, so if we have a polynomial with a factor of x minus c, then c is a root or a 0 of f of x if we find that that remainder is 0. Okay, so if our remainder is equal to 0, then we know it's a factor, and that should be pretty self-explanatory. All right, so let's take a look at the next example or exercise. So we have using the factor theorem, show that x plus 2 is a factor. So I'm telling you to use the theorem. Use the theorem. So why don't you try this on your own? Pause the video here and see if you get the same answer as me. All right, so hopefully you found that the remainder was 0. So yes, x equaling negative 2 is a root, or you could have also said x plus 2 is a factor. All right, so this is just some terminology here for exercise 3. If we evaluate the polynomial with x equaling a, if we end up getting it to equal 0, then we know it is a root or a 0 of the polynomial. Again, if we plug in x minus a, right, where we know x is equal to a, and if we evaluate that and we get 0 as the remainder, then we know x minus a is a factor. And if we have f of x being divided by the factor, if it's able to be divided in evenly, then we know the remainder is 0, right, if it's able to be divided in evenly. And then we have if a, so we're just using the variable a, if a is a root or a 0, then the x-intercept is going to be a. Right, another word for x-intercept is root. So if a is a root, then the x-intercept is also a, because they're the same thing. You'll hear me use these interchangeably. They all mean the same thing. All right, so let's take a look on the next page at exercise 4. So we're just going to determine if x plus square root of 5 is a factor of this polynomial. So if I want to use the factor theorem, again, if it is a factor, the remainder will be 0. So all we got to do, guys, set this thing equal to 0 and then plug in. All right, so what that it's not a nice looking number? You'll still get x to equal negative rad 5, and now you're just going to plug that in for all of your x values. So you can pause the video and do this on your own, or you can just follow along with me here. We're just plugging in. Hopefully pretty straightforward since we've done a bunch of these examples already. All right, I just rewrote it because it was getting a little sloppy and did not like the way that looked. And again, just plugging it all in. Making sure I didn't make any mistakes. We just plugged in x to be -5 here, here, and here. Boom, boom, boom. All right, that looks good. Just making sure I didn't forget the negative. Okay, and now we can just simplify. Negative rad 5 times negative rad 5 times negative rad 5. These combine to radical 25, which is just 5. So I have 5 times negative radical 5, which is -5 rad 5. All right, so I'm just going to rewrite this, that term is just really -5 rad 5. So let's write that down. This is -5 rad 5. Again, just going through the multiplication here. I have +2 times negative rad 5 times negative rad 5. Two negatives make a positive. 5 times 5 is 25. You're taking the square root of 25. So really this is 2 times 5, which is 10. So again, I'm just going to rewrite. This is really plus 10. And multiply these terms. You get +5 radical 5. Bring down the 4. Don't forget the minus sign. And these cancel. And we're left with 10 minus 4, which is 6. So is this a factor? No. Not a factor. Okay, again, we have our remainder is 6. Alrighty, everyone, I hope you found this video helpful. We will be continuing with this tomorrow in class.